My name is Vassilis Polychronos. I am Chief Technical Officer at GeoSense company that participates in the ICAERUS program, Horizon project. Part of let's say, the responsibilities we have in this project is the use case 5, which is rural logistics using drones. And here you can see one of the platforms we have developed in order to participate in the use case. Actually, it's kind of a cargo drone. The shape is a little bit strange, it's a helicopter like the traditional shapes of multi-rotors or fixed wings, but it serves a purpose to be in this shape. So what we see here is a cargo drone. It's a drone that has the ability to carry up to 10 kilograms of payload. The payload can be attached at the belly of the drone, and the drone accepts let's say, instructions from a centralized main platform that accepts all the requests and then assigns tasks to the drone or any drone inside the fleet of a company. And the drone executes the task, meaning what? Someone has to put the payload in, and then the drone takes off automatically, heads to the right direction in order to reach the destination. During transition en route to the destination, can let's say, face some difficulties like bad weather conditions, etc. We always have this feedback back in the back office, and we can ask the drone to deviate in order to avoid something. For example, avoid a rural place, a highway street maybe that there is a lot of traffic below. So when it reaches the destination, we can ask the drone to deliver, and delivery can be done in many ways. If there is a very secure space to land, then we ask the drone to land in that secure place, and remotely we can release the cargo box. So someone responsible there can take the cargo box, empty it, and plug it back in to the drone in order to recover it. Another way, when we have to deliver something, when we have, let's say, a non-secured place to deliver, is that we can lower the drone up to a height, let's say, down to a couple of meters, maybe 3. Also, we utilize a down-facing camera in order to verify that there's none below the drone, no one, and the space is clear, is empty. And then we can ask the drone not to land, but to release just the cargo box. And that way we can deliver the cargo, and we give instructions to the drone to leave and head back to the office. Part of the technologies, apart from the software side, we have a lot of hardware development done here. For example, we utilize open source technology for flight controller. This is a typical flight controller based on open source, and it's very, let's say, robust solution, and this becomes the main board of everything connected to the drone. For example, here is the GNSS unit, the unit that gives us the position, the heading, the speed, and also information about the compass, digital compass as well. Here you can see a mini computer, a mini processing unit. Don't judge about, don't criticize it for the size. It's really powerful, and it's also having a connected camera on it. We can use it to look downward in order to make sure that the space is empty when we have to land or to release the cargo. In this miniature computer becomes the center of all the components of the drone. As it connects to the autopilot, it connects to cameras, it connects to 5G technology in order to monitor drone and send commands to the drone even when it's beyond our communication channel, RF communication channel. And when we find ourselves even beyond GSM network, then we utilize satellite modems where we can get basic information from the drone via satellite this time, and also we can send basic commands to the drone again via satellite. And all of them assist, let's say, a control room a main control room to always have a clear idea of where the drone is, what it does, if it faces an anomaly in its electronics, in the weather conditions, etc., and also gives us an access to basic controls like abandon the mission, land where you are, return back to home, etc.